So balancing the equation by inspection, what do we need to do? We balance the carbon first. What do we need to do to the carbon dioxide on the right side?
Add a 7.
Put a 7 in front of it. That will give you 7 carbons. That will also change the number of oxygen atoms. So now how many oxygens do we have?
14.
2 times 7, 14, 14 plus 1, 15. Okay. Now we know the hydrogen is still not balanced and oxygen is still not balanced yet. Okay. Now we have 8 hydrogen on the left. What do we need to do to the water?
4.
Now we'll put 4 in here. That will give you 8 hydrogen. Now we'll also change the number of oxygen there. Now you have
18.
18. Oops. So you have 7 carbon on both sides of the equation. You have 8 hydrogen on both sides of the equation. You have 18 oxygen on the right, 2 on the left.
Let's put a 9.
Balance? Of course, you have the same number. So that's what we need you to be able to do. Another hydrocarbon. When you burn hydrocarbon, you always end up with carbon dioxide and water. So when you burn ethane, natural gas is methane. You can burn ethane in the presence of oxygen. There you get carbon dioxide and water. So how do we balance this equation? Well, we gotta So that's what we have here. When you burn ethane in the presence of oxygen, you get carbon dioxide, you get water there. When you get carbon dioxide and water, before you balance the equation, you always have 1 carbon, 2 hydrogen, 3 oxygen in there. So in this particular case, we got 2 carbon, 6 hydrogen, 2 oxygen in there. So we need to balance the carbon. Well, it doesn't really matter which one you start. And you can balance the hydrogen first. You can balance the oxygen first. Yeah. So let's start with carbon there. So you have 2 carbon on the left. We got to do something about the carbon on the right. Put a 2 in front of it. That will give you 2 carbons. And that will also give you 5 oxygen. So carbon is now balanced. We got 6 hydrogens on the left. We got 2 on the right. We're going to put a number in front of water to balance the hydrogen.
3.
6 hydrogen, oxygen, 7. Now you have 2 carbon on both sides, 6 hydrogen on both sides. So carbon and hydrogen are balanced. You got 2 oxygen on the left. You got 7 oxygen on the right. And we said if you end up with an odd number of atoms there, try to make it even. However, when you have a single molecule like oxygen, you can actually manipulate the number of oxygen atoms without changing the number of other atoms. So that's easy. All right, if you do anything about the carbon dioxide and water here, you change the number of oxygen, you also change the number of the other atoms. That will make things more complicated. Okay. Now, if you have a species that only has oxygen on one side there, and then you can change the number there to give you the equal number of oxygen. Now, what can we do to give you 7 oxygen on the left side? Well, we can use a fraction. If you do this, that's 1/2. 1/2 times 2 cancels out. 2 cancels out. That will give you 7 oxygen. But we don't like fractions. Well, what can we do? Multiply everything by the denominator, 2. So 2, 4, Now, if you do this, now we'll give you 4 carbons on the left now, 12 hydrogen on the right now, 7 times 2, 14 oxygen on the left. Okay. Now here, if you put a 4 in front of this carbon dioxide, you get 4 carbon. Okay. And then if you put a 6 in front of water, you get 12 oxygen, 12 hydrogen. Now 4 times 2 is 8. 8 plus 6. Balanced? No. That's all we want you to be able to do. Giving you an unbalanced equation, do a bookkeeping there. Try to figure out how many atoms of each kind on both sides, and then try to manipulate the number so that you end up with a balanced reaction equation. I want to show you a secret. So I love you so much, and you dedicated your summer to this very intensive course there. The best way to learn about balancing equations, well, first thing you can do is to practice. And then you do a little bit more practice. And you do even more. There is no shortcut. Sorry. I would have given you that shortcut if I know what the shortcut is. And this is the shortcut. You do practice, and you will learn the trick of balancing equations. Now, in the future there, and we will actually looking into this particular situation, a balancing equation there. In other areas of chemistry, when we balance an equation, we can focus on not only just the atoms, but we can also focus on electron transfer. A type of chemical reaction we call redox reaction, oxidation reduction reaction. Based on the number of electrons transferred, we can focus on the transfer of electron there, balancing the number of electrons first. Total number of electrons lost on one side from one particular element, and versus total number of electrons gained on the other side for the other elements there. Once you balance the number of electrons there, and then everything else becomes a little bit easier. And when you're only needing, when you only need to balance the other elements after the electrons are being balanced, and the whole thing becomes a little bit easier. So that's another approach there. More, that's not only works when you actually have electron transfer. So depending on the chemical reactions, the types of chemical reactions you're dealing with, and there are different approaches when you try to balance an equation. And now balancing the equation, sometimes it can be as easy as carbon, oxygen giving you carbon dioxide, and sometimes it can be very complex. So the best way to learn about balancing equation is to go through the practice. There's no shortcut. Okay, you have to do the practice there. In chapter 3, we give you quite a bit of questions asking you to balance different types of equations. Make sure, if you don't have the time to do it before the first exam, since chapter 3 is not on the first exam there, and finish the homework at least, and then make sure you take some more time and then go through the questions at the end of the chapter 3, and make sure you do your balancing. And remember, chem is try, so you got to try it. Okay, so that's very important there, and that wraps up our discussion in chapter 3. And we want to pick up another topic, another chapter there.